We are Sierra Tech. Today, we are going to study how the aircraft air conditioning system works. Let's go into detail.
You know, every single time we step onto a plane, we're basically walking into a place that, well, it just shouldn't be able to exist. It's this comfortable, pressurized bubble, flying through an environment that's completely hostile to us. So, how's that even possible? Okay, let's get into it. We're going to explore this hidden marvel of engineering, the Environmental Control System, or ECS. This is the unseen life support that makes modern air travel a reality.
We've all been here, right? You find your seat, you get your bags stowed, you settle in for the flight. It all feels so normal. The air is fresh, the temperature is just right. It's a space that's literally designed for comfort and calm. But here's the thing. This peaceful scene is a carefully, brilliantly constructed illusion.
Because just inches away, on the other side of that thin metal skin, is a world of absolute extremes. When you're at a cruise altitude of, say, 35,000 feet, the temperature outside is plunged to minus 50 degrees Celsius. And the air pressure? It's so low there's barely enough oxygen out there to keep you conscious for more than a few moments.
So, that gets us to the core mission. The entire job of the aircraft's environmental control system is to fight a constant, unending battle against this brutal environment. It has to create and then perfectly maintain this tiny, habitable bubble of Earth-like atmosphere while hurtling through the sky 7 miles above the ground.
And this chart, wow, it just perfectly illustrates the sheer scale of that challenge. Just look at the difference between sea level and cruise altitude. The drop in temperature and in breathable air pressure, it's not a gentle slope, it is a catastrophic cliff. I mean, without a system to bridge that enormous gap, flight as we know it would be totally impossible.
So, the big question is, where do you get the power to create an entire artificial environment from scratch? Well, the answer is as brilliant as it is intense. The system taps directly into the heart of the plane's most powerful components, the jet engines themselves.
The raw ingredient for all the air you breathe on board is something called bleed air. Now, this isn't just air being scooped up from the outside. No, this is air that's been sucked into the engine, massively compressed, and because of that compression, heated to absolutely incredible temperatures. It's the lifeblood of the whole system, but in its raw form, it is dangerously hot and under crushing pressure. Okay, so take a look at this. This diagram shows you exactly where that bleed air comes from. You can see the air being siphoned off or bled from the main engines. Or when the plane is on the ground and the main engines are off, it comes from a smaller jet engine in the tail called the APU, or Auxiliary Power Unit. This raw, powerful air is then piped directly to the heart of the system.
And when I say hot, I really mean it. Before it gets treated, this bleed air can hit temperatures of up to 400 degrees Celsius. That's over 750 degrees Fahrenheit. That is hot enough to literally cook your dinner, and yet that's the starting point for the cool, comfortable air you feel in the cabin. Incredible.
So how on earth do you turn 400-degree air into a comfortable 24 degrees? Well, this is the answer, the air conditioning pack. And this is not your home AC unit. It's a super complex machine with heat exchangers, compressors, and turbines that use the freezing cold outside air to rapidly, violently cool down that scorching bleed air, making it safe and breathable. This is the beast that tames the heat.
All right, let's jump up to the cockpit for a minute and see how this all comes to life. Before every single flight, the pilots go through this fascinating and really logical sequence to wake the system up. And honestly, it reveals so much about the whole philosophy behind Airbus design.
You see, on an Airbus overhead panel, the goal is what they call lights out. That means when everything is in its normal, automatic, ready-to-fly state, all the switch lights are off. Darkness means everything is healthy. Any light that's on is the plane's way of saying, hey, you need to look at me. It's pure clarity through darkness.
Now, here's where it gets really clever. During the pre-flight check, the pilot will press the button to turn on one of the AC packs, basically demanding air from the system. But, and this is key, they do this before they've actually started supplying any of that bleed air from the APU. The system instantly sees this mismatch, a demand with no supply, and it illuminates an amber fault light.
And this is the counterintuitive genius of the whole thing. In this very specific situation, that fault light is actually a good thing. It's a confirmation that the diagnostic systems are working perfectly. You see, if the pilot demanded air and that light didn't come on, that would be the real problem. It would mean the warning system itself might be broken. So while the pilot's eyes see a fault light, the aircraft's internal logic is essentially saying, message received,
My warning systems are online and working just fine. I am ready to go, but you haven't given me any high-pressure air yet. Feed me. It's a brilliant self-test disguised as a fault.
Okay, so once the system is fed with that hot bleed air and it's up and running, the next job is to fine-tune the environment. The A320 is actually split into 3 different temperature zones: the cockpit, the forward cabin, and the aft cabin, and the pilots have precise control over every single one.
Using these selector knobs up in the cockpit, the crew can set the temperature they want for each zone. The straight-up 12 o'clock position gives you a target of a nice, comfortable 24 degrees Celsius or 76 Fahrenheit. But you can see the full range goes from a chilly 18 degrees all the way up to a toasty 30 Celsius.
Now, here's another piece of really elegant engineering. How does the system warm up a zone if the main air supply coming from the packs is already cold? It uses something called the trim air system. Get this. It takes a tiny amount of that original super hot bleed air, the same stuff it just worked so hard to cool down, and it carefully mixes it back into the cool airstream to trim, or fine-tune, the temperature for each zone that needs it.
And that control isn't just random. The physical knobs in the cockpit have these little detents, or clicks, and each click the pilot feels as they turn the knob represents a precise 2 degrees Celsius change in the temperature they're asking for. This isn't just for feel, it's a deliberate design choice. It gives the pilot meaningful control without making the system constantly hunt up and down trying to chase tiny 1-degree changes. It's the perfect sweet spot between being responsive and being stable.
So, we've talked about extreme temperatures, clever diagnostics, and precision controls. But it's so important to remember that this entire incredibly complex system serves one ultimate purpose: keeping the human beings on board safe, comfortable, and able to perform at their absolute best. And for the pilots, this is not a luxury item. It is 100% a matter of safety. As this chart clearly shows, our cognitive performance is directly tied to temperature. When the cockpit gets too hot or too cold, a pilot's ability to perform complex tasks drops off a cliff. So a stable, comfortable cockpit temperature isn't just nice to have, it's a critical piece of safety equipment.
So what about the actual quality of the air you're breathing? Well, the system is designed to be exceptionally clean. The entire volume of air in the cabin is completely replaced with fresh or HEPA-filtered air every 2 to 3 minutes. That is way more frequent than in most office buildings. Those HEPA filters, they capture over 99.9% of viruses and bacteria. Air from the galleys and lavatories is immediately dumped overboard, never recirculated. And the air is designed to flow from the ceiling down to the floor, which minimizes the spread of any contaminants.
So, the next time you're on a flight and you feel that gentle, cool breeze from the little vent above your seat, maybe you'll think of it a little differently. Because it's not just an air conditioner, it's the final product of this incredible journey, from 400-degree engine air all the way to a perfectly calibrated, life-sustaining environment, all managed by a system working silently, constantly, just to keep you safe in the sky.
That brings us to the end of this overview of the Airbus A320 air conditioning system. If you found this explanation useful and would like to see more real-world aircraft system breakdowns, it's available for students, engineers, and aviation enthusiasts worldwide. Don't forget to like the video, share it with fellow engineers, and leave your questions in the comments. Engineer's perspective, please consider subscribing to the channel. Your support helps me continue creating clear, practical aviation content.